Ladies and gentlemen, welcome to this webinar of the World Bioenergy Association. My name is Christian Rakosch. I'm chairing this association. I'm very happy to welcome you all to our today's webinar. We'll wait for a couple of seconds for people to join. I can see that the numbers are rising rapidly, so please bear with us just a few seconds, and then we'll start the webinar. Okay, I think most of the participants will already have joined. So let's start this webinar. Once again, my name is Christian Rakosch. I'm going to moderate this event. I'm chairing the World Bioenergy Association, and we're very glad that you are with us today in this third webinar of a series of webinars that we have been organizing regarding the use of biomass from agricultural wastes and how to use it for energy generation. The first two webinars, well, the first webinar was dealing with the technology that is available to use agricultural residues. We had a couple of high-profile companies that showed us that technologies for using agricultural waste are very developed today. Agricultural wastes can be used to generate energy in a clean and an efficient way. And we had some very nice examples for that. The second webinar we organized was dealing with international experiences. We had a couple of countries that are quite advanced and really trying hard to increase the use of agricultural biomass as a source of energy. And we had some very encouraging examples there. Both of these webinars are recorded and can be looked at the World Bioenergy Association's website. So please, unless you have already participated in these first two webinars, feel free to come to our website and have a look. This third webinar on the use of agricultural residues is dedicated to a specific topic, which is densification of agricultural biomass. Agricultural biomass is usually coming in a very fluffy, inhomogeneous way. And one of the key things that needs to be done to be able to use it as a fuel is to densify it, to increase the density. And there are different approaches of doing that, either densifying it in large units, in bales, and we will have a presentation from a company that has a very high profile in baling of agricultural biomass. Could also be in briquetting, so medium-sized pieces. And again, we have a member company, CF Nielsen, which has a long history and a long tradition of providing technology for briquetting. And finally, pelletizing, so pushing the biomass together into small pieces, into pellets that can subsequently be easily stored and easily used as a fuel. And we'll have two companies, also two member companies of the World Bioenergy Association, that will present their experience with pelletizing agricultural biomass, CPM and Amandus Kahl, both also high-profile companies with many years of experience in densification of biomass. So that's the program for today. And this program, of course, also has a space for your questions. So please feel free to ask whatever question you have in the chat. And we will, after each presentation, look at the chat and see if there are questions that are of general interest and ask these questions to the presenters. So please, whenever a question comes up, do write into the chat, and we will try to answer your question either directly or possibly even after the webinar if there are too many questions. What we will also do is we will have a couple of small polls to get a little bit of a feeling for where is your interest, where is your background. And the first poll, I would like Bharadwaj, our general manager, to play in now. The first poll is just to a kind of a warm-up exercise. Who is in the room? We had a lot of people subscribing for this webinar, over 300 registrations. We have now almost 100 participants. We're very happy with this good turnout. And we would like to know, what is your personal background? Are you from a bioenergy interest organization? Are you from another interest organization? Are you from are you coming more from the agricultural side? From the processing of crops? Are you an equipment supplier? Are you a startup company or others? And if there are others, just write it into the chat. What kind of professional background you have that's interesting for us to understand who is in the room, in the virtual room, so to say. So please just click on one of these items and submit, and then we'll see who is in there. Very good. So the first questions are already popping up. Okay, so we have quite a few of you are working from interest organizations, which is great because you're multipliers and you're able to bring the information and the messages out to the bioenergy sector in your respective countries. So I think that's a great turnout. Other interest organizations and a lot of equipment suppliers, in fact, and a lot of others. So if you would like to let us know from what other affiliation you're coming, just write it into the chat, but you're not obliged to do that, of course. So that was the warm-up exercise. So we now know approximately who is in the room. And after this warm-up exercise, I would like to start with our first speaker. It's Olaf Naring from Amandus Kahl, a company that has a long tradition in producing biomass pelletizers. Olaf, the floor is yours.
Yeah, thank you. Thank you very much, Mr. Rakosh. Let me share the screen and okay. Yeah, good morning, good afternoon, ladies and gentlemen. It's a pleasure being here and representing here my company, Amandus Kahl, today. And the topic here is pelleting of agricultural residues. And so my personal experience is this industry is, I do business in Asia Pacific region, so I have a lot of tropical agricultural residues, and some of these I will highlight later in my presentation here. And of course, I also know how to pelletize the usual ones. For example, here in Europe, the straws when you have from wheat or corn, maize straw, and other straws, even grasses. And when we go further, then we can also see that already for many decades, a beet pulp, for example, is pelletized. But this is now more an animal feed topic. But let's talk about pelleting of agricultural residues more on the energy sector. You may know Amandus Kahl is an independent family-owned company. We call ourselves still medium-sized company. We have more than 900 employees worldwide. And we are also a member here in this World Bioenergy Association, and a very, very proud member. And we appreciate all the works of this association, especially as it brings the topics that we have as a supplier together with the other parties in the industry together on the table here. It's very interesting. Amandus Karl is a company here made in Germany, and it's everything from a single source. We can build complete plants. So with engineering, with manufacturing of equipment here in our facilities in Germany. Then we have erection, assembly supervision, startup and commissioning, and also after sales service, and all done with our own people here from Rheinbeck in Germany. And you may know that we are basically the sole maker of real industrial flat die pellet mills. And our industry flagship today in the biomass industry is our 65-1500 with 630 kW. And this has on the wood and other biomass, it has already a basic capacity of 10 to 12 tons per hour. No? And today we also see more and more people adding steam. And with the addition of steam, this pellet mill becomes even more efficient. And then we see the capacity of up to 15 tons. For example, this is done in the North American wood pellet plants where we have the large scale installation a lot now, where the people achieve these 15 ton with a single pellet mill. And only applying 630 kW is a very energy efficient machine. Nevertheless, at this efficiency, it still provides for highest PDI and bulk densities. To supply the pellets according to the standards in the industry. And it has the lowest energy consumption and operating costs of all pellet mills in the industry today. When it comes to roller lifetime, bearing lifetime, grease consumption, energy consumptions, downtimes in the end, available operating hours is a very, very feasible pellet press. So, and these advantages we can see clearly in the rising market share of this pellet mill in the global pelleting markets. And now how does it, sorry, I have to start this video maybe. Now, how does it work, the flat die pellet mill? Now the material comes from the top and falls into the large press chamber where the rollers are rotating on the die plate. You see multi-roller system, and these rollers press the material through the die plate and shape the pellets. So roller numbers are typically 3 to 6. In the big machines, we have 6 rollers, and these rollers are big and they have also large roller bearings inside. And this is important for the long lifetime of the roller bearings and the very low grease consumption. And the big press chamber provides sufficient space for the material to fall into the press chamber and being distributed and pelletized, which is very important here for the low bulk density fiber that we usually have in the agriculture residue. So now comparing wood and agriculture residues, I selected these 2 photos here, logs and chips, and we can see that it looks like a very regular product. Yeah? So the logs are nice and neatly stored here, and the wood chips also good shape. So it can be also sawdust in the wood pelleting, because many wood pellet plants are attached to a sawmill. So, but these are monoproducts typically in large amounts. So a wood pelleting plant has different requirements when it comes to, for example, in the intake section. And this has to be considered when we now have agriculture residue pelleting plant, where the raw material looks differently. This photo also shows pellets made from some agriculture residues, still neatly arranged here. This is to give an idea, but the reality is a little bit different for these agriculture residues. So, and this we have to consider in the pellet plant here, as mentioned. So, but what do we have? Mr. Rakosh mentioned already earlier, no? But we also have high ash contents in these agriculture residues. So we have to do something against wear and tear to have long, stable production runs with the pellet mills. We have high contents of undesired minerals and chemicals. This is somehow what is not desired by somebody who wants to burn it. So typically we have lower calorific values. Then we have to consider seasonal availabilities. So when you have bagasse or other plants or straws, they come in a certain season of the year. Then we have to see what to do with the storage of this material in the meantime, and to prevent some processes, fermentation processes. Typically, these are challenging raw material properties. We have to question the homogeneity of the material compared to sawdust, one can assume that, for example, agricultural residues don't have this homogeneity. They may differ. Then I mentioned earlier fermentation processes. While wet, well, something starts to rotten maybe. And in the agricultural residue, also contamination during the collection process with soil, sand, whatever can go into this material has to be also considered. And then we have the low bulk densities and usually also more poor flow abilities. So as mentioned, my background is Asia Pacific. That has brought me to many biomasses to be pelletized, which are maybe for Europeans a little bit odd, but in Asia Pacific, very common. Oil palm fronts, we started already in the 1990s. And each year, the lowest row of branches is cut, and then something can be done. And one thing is really to pelletize and to make it as a fuel or as an animal feed here. Or empty fruit bunches from oil palm. So each oil mill has these kind of a dump where they put the empty fruit bunches and store it. So here they still look somehow neat. But when you get closer, you will see it's a very fibrous material with different characteristic in each bunch. So we have loose fiber ends and we have a tough pinole in the center. So that's what we have to consider when we process this. Bales from straw and grasses, they look completely different now as an agricultural residue, already processed in one step here. And if this goes to a pellet plant, of course, we have to look how to handle these bales, to cut them and to get them flowing into the plant properly. Bagasse, you can see here our old leaflet is already a topic from the 1970s. So it's a very traditional material to be pelletized. And it's an irregular product in size and shape. And you can see here the hand with the bagasse fiber in the hand. And then we have the husk and shell fractions. We have rice husk, sunflower seed shells, oat shells, faba bean husk. Could be all these kind of here. And when we have these as a raw material, they are already good. They are usually dry, which is very good. One can save money. Then one has to consider maybe a grinding step, and then it can be pelletized. And I can tell you these materials that you can see here with a Carl flat die pellet mill, you can pelletize directly without any grinding step before pelleting. And then we have the light and fluffy ones. For example, here hemp fiber or the cottonseed husk and linter. And these materials are even more challenging because then we have to consider also how to let them flow through the plant properly, that we don't have any bridging, clogging in the lines. And when we have, for example, a storage, an intermediate storage buffer bin, then we need, by all means, we need to have some mechanical discharge devices. So better not stop this kind of material when pelletized, let it flow. It's the best option. How to differentiate now when it comes to, now I talk about pelleting here, the agricultural residue and byproducts. And the typical plant is, can look like from A to Z. You have a debaler, a crushing. Then it comes to the wet grinding crushing. We have a drying, and we have dry grinding followed by pelleting. So according to these processing steps, now we can categorize different raw material grades here. So for example, on the left-hand side for debaling crushing, it's typically for bales, now from grasses and straws, can be also here empty fruit bunches, which will go into this process. When they are wet afterwards or before, then you can go to dry grinding directly. We have coarse wet harvest residues, bagasse, oat palm fronds, corn cobs, others, maybe also EFB when they are smaller. They go to wet grinding crushing. Fine wet harvest residues, for example, if you have already chipped maize straw, then you can go straight to drying. And then if these materials are already dry from the harvesting, then we have, for example, coarse and dry materials as rice husk and any other husk, and also corn cobs. And these need to be ground then before they can be pelletized. But as mentioned, if you have a Carl flat die pellet mill, usually this husk you can pelletize directly without further dry grinding. And fine and dry materials, again, like husks and others, you can pelletize directly. When you have, for example, the Carl flat die pellet mill here. I don't know now for other pellet mill types, I think you need to do the dry grinding anyway. And with this table, you can differentiate the different raw materials, and then you categorize the steps required. And I'd like to give you now an example on the processing of empty fruit bunches, how this can be done. And this comes here, this concept is a concept we use already in Malaysia and several plants. It comes with a Carl pan grinder mill, and the Carl pan grinder mill, you can see here on the screen, it looks like a Carl pellet mill. These are the machines left and right in the center. And the difference here is that with the pan grinder mill, you can reduce particles in size and fibers in length. So for the empty fruit bunches, there's a wet shredding process before, and these long wet fiber can go into the pan grinder mill, and then we make fluffy pellets. So you can see here on the lower side here on the screen, these are fluffy pellets made with a pan grinder mill. We use this pan grinder mill also for wood chips and other fibrous materials, and to grind them and to reduce the fiber size. And here it makes these fluffy pellets then. And these fluffy pellets you can bring to the belt dryer, and where we can have a very homogeneous distribution on the dryer belt, and where we can achieve a very homogeneous drying result, which is very essential here for the pelleting process. We have to consider always particle size and moisture and homogeneity of these characteristics. Homogeneous moisture content is very essential for the good pelleting result. And with this material, we can handle this and achieve it. And then afterwards, these materials, these fluffy pellets as they are, can be pelletized with a Carl flat die pellet mill directly into hard and solid EFB fibers. And this process you can adapt also for other bio agriculture residues. And what we see today is also that in certain markets, people will use the pan grinder mill to make something like a densified, not a full densified material, but a semi-densified material, and use this already as a final product. And because this characteristic are achieved already good enough for their purposes, to reduce transport costs, the logistic costs, and having this kind of densified material, which has very good flow properties, and then they save the hard pellet step. This kind of semi-densified steps is also already well known in the waste pelleting, where it's called fluff. And here the same we see now in the biomass and the agriculture residue pelleting industry also, that people not always go for the hardest pellets. Sometimes they are satisfied with a medium hard pellet, which can be achieved here. One also has to look a little bit into the moisture, that it can be pelletized at 20%, maybe at 25%. And this one is pelletized here at 45%, and you have already achieved this good pellet structure here. And I think this is a very, very unique application for a Carl pan grinder mill. And if you want to make hard pellets after drying, you can pelletize this easier to make a hard pellet. Okay, summary for us here, pelleting of agricultural residues. It's a very interesting alternative fuel raw material. And we know that people more and more look into these raw materials because they are cheaper. They are really also available as a fuel, and they want to do something. But we need to do an adapted process according to the raw material characteristic. We have an adapted size reduction process. You saw the different characteristic the raw material can have. This we need to consider in a plant. We have to apply wear measures against high ash content and the consideration of the large volume flows to be handled. And these large volume flows also need to be processed in any machine in the process. So, and here, of course, the large scale pellet mill as a Carl 65 1500 and other models, but they have the space to handle these materials at high capacities very well. We have to look into the consideration of low operating expenses. And That means long production runs, long lifetime of the parts used, for dies, rollers, and bearings. Low energy consumption and grease consumption, because it's an agricultural residue, so the value is not the highest. So we have to look very, very well into the feasibility of the overall process. And what we also see is now optional value adding by washing processes, steam explosion processes, where we also supply already equipment to. And of course, I think everybody knows already the torrefaction processes to increase the value adding before doing the next step as pelletizing. Okay, I'd like to thank you for your attention, and we'll hand over to the next speaker then. Thank you very much.
Thank you very much, Olaf. That was a brilliant overview of what you want to know about pelletizing when you think about agricultural raw materials. So that was really great. Thank you. And I have two questions from the chat that I would like to put forward. The first was, do you have any experience with pelletizing sweet sorghum stalks?
Sweet sorghum stalks. Basically, I'm in person not, but I know these questions we have also from Australia now. And today, I think the important one, I'm sure you can make a pellet out of sweet sorghum. That's stalk. That's not the point. I think I have to look into the raw material as it looks like. How is it collected? How is it harvested? And then to decide how to design the intake section of the plant and how to design properly the required flow of the material in the plant. It's always how is the shape of the material, what is the bulk density, and what is the moisture at the intake point of the plant. These are the crucial ones first to identify, and then to select the suitable equipment. And then afterwards, once the material is in the line, in the flow, then we have to make sure that we have an even drying result, and that in the grinding and in the pelletizing, we use the appropriate amount of energy only to make a good pellet.
Yes, thank you. And then there was another question. Do you also offer mobile solutions?
Yeah, this question is a very familiar question, and I think we know that there are some parties in the industry making mobile units. We as a maker of equipment, we do not provide this, because this is a different segment. When you come to mobile units, they go onto the road. They have a complete different regulation when it comes to local authorities to fulfill, and that's not our business. But of course, you can put in a certain size of equipment on the mobile trailer and move them from side to side. And we know that there are players in the market handling this. Okay.
Let me ask one more question, Olaf. If you think about the total costs of pelletizing a raw material, could you give a breakdown of the different cost components? How much is capital cost? How much is energy cost? How much is personal cost? Do you have some very rough idea?
I think I saw this question, and actually I said it's difficult to answer this. As I said, what kind of raw material do you have here? How much energy you want to spend? You have 150 kilowatt in the total plant. You have 200 kilowatt. What is the drying requirement, and what are the other local requirements, and what size of plant do you want to have? And I think it's very challenging. There was somehow the rule of thumb, the yearly capacity times 100 euro. This is the budget what you have to allocate. But I think it's to give a very precise information now here. This is a little bit challenging.
Yes, I understand that. So the variety is just too large to give any specific figures, right?
It's indeed. It's if you have a dry material, the easiest material to pelletize is we saw this when we have sawdust, or when we have a shell that can be pelletized directly. Then we only talk about the pellet mill. So then we talk about when you want to do now in the range 5 to 10 ton, you talk about maybe a single pellet mill from car. Then we talk about 500,000 for the pellet mill with accessories. Then you talk about an energy consumption of 500 kilowatt. And then you talk about 500, and you have 50, 60 kilowatt hours per ton for these for agricultural residues, maybe a little bit higher than in the wood, depending on the densification process. And then we have the spare and wear part cost, depending on the ash content, can be a little bit higher. So then we may talk about €3 to €4 for the wear parts. And then the labor, okay, this really depends on the place where we are. Now, what is the cost of a person? But then we have also talked about the availability of the plant, and do you achieve 8,000 hours running time, which is a very beneficial for the operating costs? Or if the pellet mill is not so good as a car one, then maybe only have 6,000 hours, and somebody else can collect on his own then for the OPEX.
Sure. Well, still, that was an interesting insight you presented now. Thank you very much, Olaf.
Sarakos, thank you. Thank you very much.
And with this, I would like to involve our participants shortly with another short poll. Bharadwaj, please, can you put in the next poll? Excellent. So the question is, you're coming from different backgrounds. What kind of feedstock for densification are you most interested in? Are you more interested into cereal straw, corn straw, rice husks, sugarcane bagasse, sugarcane straw, residues of crop processing like peanut shells, or any others? And if there are others, you can mention them in the chat. Please give us your answer, because that's interesting for us to see where is the focus of interest for the time being in this broad field of agricultural biomass that can be used. Please select what you are most interested in and submit your answer. So let's see what the answer is. So that's quite an even distribution. So there are a lot of residues that there is an interest in. It could be cereal straw, corn straw, rice husks, sugarcane, residues of crop processing, others. So quite a wide distribution. That's interesting. So there are a lot of byproducts that we are interested in, and in fact, that reflects the huge potential in each of these categories. I mean, in each of these categories, there are millions or even hundreds of millions of tons of biomass available that could be processed to become a source of energy. So I really believe that there is a huge potential in all of this, and the interest in our webinar kind of reflects that. We have, by the way, now already 120 participants, so we're very happy for this turnout. And this gets me to our next speaker, which is Jesper Madsen from CF Nielsen, and he will talk about another technology of densification, which is the production of briquettes. Jesper, the floor is yours. Please share your screen.
Thanks very much. I'll try and share my screen, which is this one, I hope. Yeah, just again, as a start, welcome to this webinar. And my name is Jesper Madsen, and I'm the Managing Director of CF Nielsen. I've not been into the business so many years as I think most of you other guys have been. I've only been here about 1 year. So my experience about a lot of strange kind of agriculture residues is maybe a little bit limited, but I'll try to answer the best way I can. Just to start, CF Nielsen is a Danish company, and we have more than 130 years on our back. We have not made presses since 1889, but the last 60, 70 years we have made briquetting press. So we have some experience in doing this job. We supply briquetting solutions all over the world for industrial type of briquettes, for use in big boilers at heating plants, and also log type of briquettes to be used in fireplaces and owned by private consumers. We have several hundred briquetting presses in operation spread over 5 continents. We produce the most part ourselves, mainly to maintain a high quality level and also to be flexible, to be able to change things rapidly, and also to have some rather high level of quick delivery. So that's one of our key points, that the vital process we keep in-house to be able to control them. To take about the products, we have 2 principal in presses. We have the mechanical press, which is you can see on the picture, is a press that can do from 200 to 3,000 kilos per hour. Round or square, 50 millimeter to 120 millimeter, and can make density about from 0.9 to 1.2. Another line is the Shimada, which is an extruder press, a little bit less capacity, up to 600 kilo per hour, and also made this special briquette size and shape, I think you might know as the Shimada briquette. Very high density briquette, and very good for instance, pizza. If you take the main product, which is our mechanical press, the construction is equal to the construction of an eccentric press. A constantly rotating eccentric is connected to a piston, and that compress the raw material into a conical die and make the briquette. We have sizes from smaller ones from 150 up to 3,000 kilo per hour, and in various type of shapes and diameters. Our solution is mainly considered to be into these regions, which is the industrial, which is, as you can see, the presses are placed underneath the silo, and then we have a cooling line, and then the two container where you take the briquettes and bring them to, for instance, a local heat plant, or to process in the industry area. We have the agriculture solution way where we can make complete solution for briquetting not any, but almost any agricultural waste, and have a capacity from about 500 kilo and up. And we have a straw baling system where we can handle straw coming into the system in bales. Consumer solutions, which is a complete line with saw, breaker, and packaging equipment. And in the end, we could have also an automatic robot packing line. So in fact, you're going to have a pallet of 1 ton of briquettes coming out ready to ship to customers. Capacity for consumer is around 1,500 kilo per press. And again, briquettes from 60 millimeter up to 100. I can also make a complete line making Shimada briquettes, which is, well, a little bit out of our normal league. Normally we have the main press, and main press supply is the mechanical press. We also have a division that can make total engineering, meaning that we can make complete lines of conveyor, shredder, filter, furnace, and silo and presses, and then out to the end user, where we're going to be in this case in containers, and can briquette wood, agricultural waste, or other biomass. The output that we produce is then briquettes in different shapes, different forms, diameters. So the variation is pretty big. Sometimes it's customer specified how they would like the briquette to look like. If you come to raw material, agri, we have different types. We have peanut shells, corn stalks, rice husk, coffee husk, a lot of straw, napier grass, and miscanthus. And as the previous speaker talked about bagasse, cotton stalks, and a lot of more. Be able to more or less compress everything. The advantage of the focus area we have is on the agri waste, which is in many countries, the agri waste is burnt in the field, which means it's going to be free, almost free, or very cheap. raw material to be processed afterwards. Burning is polluting and has been prohibited in many countries, and that's why there's also going to be in the future going to be an aspect we have to take into consideration. Forests then are being depleted, and agro waste can be turned into fuel, which is, I think, the next step into getting our CO2 step ahead, which we all are working for right now. Including government incentives are available, and that also would push this way in the right direction, and also to be able to supply this briquettes for getting incentives from the government. What is then the typical use of agro briquettes at present? We use briquettes for heating, the process industry. Use it for consumer, for cooking. We have made several installations and several projects in Africa where they use briquettes to heat up these small stoves instead of going out and cut some wood down. And then we have for consumer, the consumer heating area is also rather big. What are the specs then for making a good briquette? Need to have, to a certain degree anyway, a homogeneous raw material. A humidity between 8 to 14%. Sizes 15 to 20 times 3 times 2, screen 10, 15. And hopefully, or preferably, a low ash content. But that's going to be, as Olaf said earlier, very difficult to get this, because we are into this agriculture business, and a lot of they have more or less all of these products have a lot of ash. And that will lead to a high wear on the system. What are then the differences as we see it when we talk about agro versus wood? We have a larger volume to be densified, density typical below 100 kilo per cubic. So we have modified our inlet system to be able to cope a larger volume in the press. The structure of agro materials requires a different die system to be able to make a solid briquette. That's why we have made a longer die system specific to have higher counter pressure in the press line and then make really solid and stable briquette. And then we have the ash content in agro, which is normally a lot higher than in wood residues, which set up high requirements to the die components. Because by that, we have made special die wear rings, piston tops, and compression screw tips made out of special hardness steel to prolong the lifetime of the wear parts, which is very important to get a operation running and also running at a reasonable cost. Where do we then see the new market for agro waste, for products? We have a different sector of our company called Kinetic Biofuel involved in supplying briquettes into biogas plants. The picture you see on the left here is from an installation we have in UK. And the principle about this is that we handle straw from bales to briquette for industrial scale production based on straw and slurry. And what happened is that when we briquette straw, we made some small steam explosions, which change the structure of the straw, which will enable it to absorb more than 7 times more than normal straw. And that, of course, in the biogas plant, very important that the straw is able to absorb as much liquid as possible. And secondly, of course, the briquettes give a logistical advantage when you go from loose straw down to solid briquettes. If you put straw briquettes into biogas plant, you are able to double your biogas production with a yield of 300 liters of methane per ton, corresponding to approximately 200 liters of methane per ton straw. And that's a very important issue when we talk about getting a biogas plant to operate in a reasonable way and giving a good output. And this process, by using briquetted straw and put that into a biogas plant, this is a process we have patented in that company called Kinetic Biofuel, which is our own company. So we have a lot of installation going on at the moment, not only in UK, also in Poland, several places in Denmark. And we're looking into this area as a huge market for us to be able to make briquette presses or briquette press installations to supply biogas plants, and then to be able to expand the amount of methane you are able to produce in a given biogas plant. Another is, which might be something that we see coming in the future, is the briquette of wine stalks, doing to customer or industrial use. If you take a vineyard like this one, we have approximately 1 to 1.2 kilo wine stalks per year cut out of each of these wine plants. That equalizes about 3 tons per hectare. And if you consider the total area worldwide of vineyards, the amount is very, very large. And you're not anymore allowed to burn this on the field, which they have done for many, many years. Now they have to collect it, which you can see in the center, and then they have to do something with it, which could be to shred it and to make briquette, and then use it for industrial, or also use it for consumer. Especially in the South Europe, we see this as a huge potential. Well, briquette of bagasse is not new, but we have been working on this area for 5-8 years now, and just to show you a little bit of the amount of bagasse raw material we are working with this huge mountain of bagasse raw material. You see the bagasse factory in the right side, and our press installation inside the building. And then you see the end product, which is briquette of bagasse to be used for instance, for the tea industry, where you have a huge use of wood to be able to dry the tea plant or the tea plant down to be able to pack it. So bagasse in Africa anyway is a huge potential for us to work with, and to set up the correct plant is another issue, which is in Africa in general a little bit problematic. Financially, it's not easy to raise capital, and also to work in these areas could be, to some extent anyway, problematic. Then I just took a couple of others markets for agri waste, which is not into heating or energy, which is the first one is briquette for bedding. You see the bales here, and we briquette it into briquettes that could be used for bedding for animals, for pigs or for cows or for horses. Another maybe a strange use of briquettes to use it for pigs, where they actually can compress these raw material and use it into this holder, and then the pigs can go and eat it. And you can add different type of minerals or whatever you like to this briquette. So the pigs get, the same time as they eat it, they also get small pox out they can play with, which is in fact a regulation now coming in Europe that you need to amuse the pigs so they don't attack each other. And then the gasification area is also something that is seems to be moving rather quickly. We're not into a lot of project like this so far, but the future looks promising, and we think that's going to be something we have to look into also in the future. As the other speaker mentioned, to be able to make some kind of OPEX or calculation of if it makes sense to make an investment in a plant, a briquetting plant or not, it's very, very much depending on the raw material, on the local cost of raw material, the sizes, the working cost, the electrical cost. So it's a lot of parameters that makes it very, very difficult to come up with some kind of sum rule of the cost of implementing a factory in a given region. Okay, that was my short presentation. And if you look at our website, you can see several videos of customer installations and a lot of information about CF mills in general. So thank you for listening, and hope you have some questions which I might be able to answer.
Thank you very much. That was extremely interesting, Jesper. and quite also impressive how long your company has been already engaged in producing these presses. I would like to ask you a question of orientation. I mean, when would I consider to make a briquette, and when would I consider to make a pellet? Could you give us a hint? What kind of criteria are relevant to decide whether a briquette would be more suitable or a pellet would be more suitable?
I think it's, of course, depending on what the purpose should be and also the volume. If you see our volume compared to what Olaf just showed, where it was 10 to 15 tons per hour, our maximum is when you talk about straw, maybe about 2 tons per hour. So the sizes is one thing that have an impact. Of course, also depending on what the use of the briquette or the pellet should be in the end. For some of our, like saying the consumer, of course, it will be better for household consumer anyway, to handle briquettes made of a certain diameter. So we go down from 60 to 120 millimeter, and I think pellets is maybe going up to 18, 20 maximum. So it's a little bit depending on the users, and costly. I'm not sure who's the cheapest or who's the expensive. Maybe we should talk to Olaf about this. I think these costs are very difficult to give a key figure on, and also at some rule we cannot do that.
But the point is, I mean, the costs obviously depend very much on the raw material, the local circumstances, etc., etc. But it's not possible to say briquetting is cheaper than pelletizing or the other way around. It depends on too many factors. Is that correct?
Yeah, I think we cannot just say that if you have this type or this volume, again, it's cheaper to go to. I think again, if you have a very high volume, if you need to briquette 100 ton or 5 or 50 ton per hour, then I think to go out and buy briquetting, like our briquetting press, would be too expensive. But we have some advantages also in regard to moisture content and to differences anyway, to moisture content and to particle size, where we maybe are a little bit more flexible than the pellet presses. And that's yeah, and that could mean a difference for some customers, that they have the possibility of sweating or making that small sizes or dry it that much down. But in other cases, it would be better to buy a pellet press. Yeah.
Right. Now, one of the issues I think that's particular was also already mentioned by the first speaker is the contamination and abrasion of agricultural residues. Would briquetting also be less sensitive to abrasion or contamination than pelletizing? What's your...
Well, we have tried to take some steps against it by making this our what we call agriculture press different than from a regular wood residue press, making these the wear parts very changeable, and that's why we try to kind of avoid the high cost of changing everything. So we only change parts of the press which have a high wear, because the high wear of agriculture residues is, I don't think you can really avoid that. It's a lot higher than the ash content is a lot higher than in normal wood. So I wouldn't say that we are we're better than pellet, but we take measures to avoid this high cost of the contamination.
Thank you. Thank you. That was really an excellent introduction into the issue of briquetting. And I would like to now go to our next poll. And this poll will be looking at what kind of use of densified biomass are you most interested in? Also, again, to get a feeling, where is the interest of our viewers? Is it into domestic cooking? It was mentioned as one way of using briquettes in Africa, for example. In domestic heating? Is it commercial heat production, industrial energy generation? Is it as a use for feedstock for biorefineries, more prominent topic recently, or would it rather be for animal feed that was also mentioned already in the first presentation? Or are you thinking about exporting fuel for power plants and you want to densify? So please let us know where is you're interested in regarding the application of densified agricultural biomass. Just tick whatever is of relevance for you. You can do multiple choices and submit. So let's see the results. Okay, so again, a relatively even distribution, but with a focus on industrial energy generation. So 56% of participants said they are interested in using densified biomass for industrial energy generation. Makes a lot of sense. Sorry, makes a lot of sense, obviously, because there are so many, there is so much energy need in industrial production, and very often also even related to the processing of the biomass that can then directly be using the residues. So could be domestic cooking, domestic heating, commercial heat production, use as feedstock for biorefineries. So lots of different applications, in fact, and with a slight focus on industrial energy generation. Thank you for this. And this leads me to our next speaker. And that is, again, a very, very interesting application. And then the third relevant technology that we're looking, Javier Vega will give us a presentation on the baling of biomass. So producing large chunks of biomass rather than small or medium-sized chunks. Javier, the floor is yours.
Thank you very much. Thank you for the invitation to our company. And we are very pleased to be here with you. This is the interesting webinar, okay? I will start presenting briefly our company. We are a Spanish company based in Madrid. And we provide baling solutions for different industries, biomass, recycling, waste, and even metals. We have our own factory in Madrid, as you can see, using all kinds of technologies. We are trying, like other companies that were priorly, manufacture the balers by ourselves, cutting, designing, installing all elements of our balers. And we are trying to use the best technology, the best innovations, the best hydraulics. We are selling quality, you know. We are very international. We are more than 3,000 installations around the world, especially in third countries, in Russia, Kazakhstan, Mexico, South America, even in Indonesia, and other countries, and our own offices in USA, Mexico, Argentina, and so on. We are exporting more than 65 of our machinery. We have all type of solution for biomass and agriculture products in general, okay? We have experience in baling straw, which is straw, rice husk, peanut husk, vine, cotton stalks, sugarcane, and so on. Regarding the baling, it is important in our technology for big amounts is to have in mind the time system. You know, the historical, we were using wire as a time system, but the new requirements, and I am sure that in biomass will be critical in the future to have PP twine, it's polypropylene. We have the new time system for this type of system, you know, for this type of products. Also, we can bale not for biomass, but for animal feeding sleeves, or even strapping. We have a huge range of different products for balers, small bales for small bales, big bales, even complete plants, even with robots to handle the bales, okay? And a different solution, even bale breakers. As you can see, we have a lot of different installations for alfalfa, wheat straw, corn stalks, and so on. Not only stationary solutions. Sometimes somebody mentioned before about mobile solutions. For example, you can see one rice husk. In fact, it's a stationary baler installed in a platform that you can move, you know. For example, if you see these two balers are installed in Pakistan in a biomass factory, you know, for agricultural residues. You know, a lot of different systems depending on the product, depending on the moisture. You know, it's very complicated, as my colleagues told us before. Different solutions, hybrid systems with different formats in case needed for several materials. You know, for example, I will try to explain you briefly one of our most interesting business case. For example, we sold 3 balers in Stora, for Stora Enso and Packages. Is one of the biggest Pakistani companies. This company is a paper mill. They are producing cardboard. But you know that in Pakistan, they have electricity shortages. And with these agricultural residues, they are burning these materials, and they are producing electricity for their factory. In this case, you can see how is coming the product from the field, how is baled, you know, and even baling on the field. Trying to, the key factor for us and for everybody today is to take advantage of the logistics to reduce the transportation cost. This is our specialty in our machinery. You know, it's a proven machinery, very hard, a long life, you know, and we're introducing technology, but simplicity, you know, because the maintenance should be very, very easy, you know, not a lot of spare parts. We are taking care of all details because we prefer that our customers have a lot of profit, have a good yield with our machinery. Is the total cost ownership of our machinery. We consider this is one of the best relationships. Okay, we have another examples. For example, about rice husk we have installed in India, in Portugal, in Spain, Australia, and Argentina, for example. We have a huge experience regarding baling this product that is not easy to bale, okay? Even with mobile solutions. Peanut husk baler. You have here one example. In this case, is a big company, one of the biggest company producing nuts, peanuts in Argentina. They purchased 2 balers and they have their own biomass plant. They are storing these bales, and after producing energy. You know, alfalfa, hay, you know, in this case, we are talking about animal feeding, you know. USA is the biggest exporter, but Spain is the second exporter in the world. Now, a lot of alfalfa is exported to Arab countries and China and other countries. It's a huge market and increasing. You know, we have special bales designed for alfalfa and wheat straw. Wheat straw could be as a biomass or even as an animal feeding for fiber. You know, that's why we are learning every day about how to bale properly wheat straw. Other type of solutions, hybrid system. For example, this baler is installed in Canada. Okay. The key factors, you know, we are trying to have the suitable solution for each product, depending on moisture, depending on the specs of the product, the fiber, the length of the fiber, you know, the humidity, even environmental conditions. For example, we are striving a lot with which straw, you know, but consider, or even alfalfa, you know, for example, with hay and alfalfa, there are several cuts in the season, you know. The moisture and the density that is entering in our balers is not the same depending on the cutting, depending on the hour that you are cutting on the field, and depending the process. Or one province, for example, in Spain, the material differs from another province in Spain. Imagine when you are talking about different countries, different products. That's why it is very suitable to study carefully the conditions of the material, the length, the fiber length, the moisture, and so on, and to have experience, you know. For us, always, for our customers, always the target is the same, is to optimize the transportation and storage, you know. For example, with which straw. Sometimes the density is very, very low. Could be even 20 kgs per cubic meter. And additionally, when you are baling which straw, the problem is that the which straw, for example, has a flexible memory, you know, we need to kill this memory. That's why we are designing even more powerful balers, especially designed for which straw, with a lot of different technical details in order to optimize this process. Because at the end, the most important is to achieve the maximum loading in container, for example, because we are talking about commodities. Our customers are exporting from Spain to China, from USA to China, or for Saudi Arabia, or for Emirates, to Emirates, you know. That's why for the last, my company has been manufacturing this type of balers for the last 50 years. But from the last 8 years, this market increased a lot, especially in animal feeding and biomass. And that's why we were innovating a lot in different systems, formats, bale size, time system, and so on. And it still continues the process, okay? Well, Mr. Christian Rakos asked me about some figures, you know. For example, we have a model for rice husk. We have this model installed for the last 20 or 25 years in several countries, in several continents. This baler is not so big. It is able to produce from 7 to 9 tons per hour of rice husk. What is the issue about the rice husk? It is very difficult to have this bale stable. You know, you need several technicalities to achieve, to bale properly this material. For example, talking about which straw, okay, this is a good example. Now we have a baler, in this case H300, normally is comparing with our electricity power, is 300 horsepower. This baler, in which straw is able to produce from 15 to up to 20 tons per hour. But pay attention about the length fiber. Let me give you one example. We sold one machine to one customer that the length fiber was this size. Officially, he was chopping. And supposedly, the length fiber was 10 centimeters. But in fact, the grinder was not chopping, only giving one cut, you know. But the performance of 10 centimeters fiber is in another baler that I don't have here the details, is 8 tons per hour. But if you are not chopping the material, the performance is reducing by half. In this case, the performance was 4 tons per hour. Okay, that's why when we are giving these figures are approximate, you know, it's not accurate, exact, you know. And for example, with corn stalk baler, for example, the baler that we have, the press baler that we have in Pakistan, one of the balers that you have here in yellow color, this with 120 horsepower is able to produce 10 up to 15 tons per hour. Again, in mobile solutions, you know, the critical issue is not the performance of the baler. The baler is optimized to move the baler and to produce bales continuously when you are receiving material. The problem is when you are loading on the field, you don't have a conveyor, you have a loader, and the quantity of material that is entering into the baler is not regular. You are reducing. And this is very logical for everybody here. You know, if you are not feeding properly the baler is not producing. You know, the baler is only producing the material that is receiving. It's like one example, okay? Another figures that I would like to share with you, for example, is the horsepower, the kilowatts capacity, for example, for this rice husk baler is approximately, the energy consumption is 35 kilowatts approximately, okay? Sorry, in which straw, it could be 4 multiplied by 55 kilowatts, and roughly running per hour is 185 kilowatts approximately, you know. And in corn stalks, in this case, we install a diesel motor, or even it could be feasible, we can install also a diesel group in case needed, you know. I think that with these figures, you can more or less have some ideas about how it's running, okay? In fact, we are trying to be a one-stop shop for biomass baling. We are very innovative, we are experiencing, we are very international and willing to cooperate with you. And if somebody needs more details, please don't hesitate to contact us. And of course, you are welcome to visit us in our factory in Spain when this horrible COVID finishes, okay? Thank you very much for your opportunity.
Thank you very much, Javier. That was also extremely interesting and quite amazing what you're able to achieve. I mean, even considering that you are able to bale something as fluffy as rice husks is, to me, amazing. So I cannot even imagine how that bale would ever stick together. So great achievements. If you look at the utilization of these bales, Javier, would you say, I mean, looking at the energy side, not looking at the animal feedstock, because obviously that's a different story, but if you want to use these bales as source of energy, would the typical process be that these bales are then consumed directly in large combustion units in industry, or would these bales be then later on maybe also ripped apart and then briquetted or pelletized? Can you say something about that?
Well, as far as we know, you know, because sometimes our customers are selling this material and they are not sharing with us what are they doing with the materials, you know. But in general, for example, rice husk is, we know that to deassemble the rice husk bale is very easy, and it seems that they are burning directly, but probably they are also producing pellets or briquettes. Sure, okay. Regarding which straw, we have two markets, you know, animal feeding. In this case, they are after receiving, at the end, they are mixing with other materials, and this is another market, you know. Regarding which straw, the issue is now has value as a animal feeding, especially in Spain and in Europe, you know, in general. But we don't have more details, you know, because we are more focused on baling and selling these machines to the customers. And specifically in rice husk, there are also alternative uses, you know, not only for burning, you know, also for animal for the bedding, you know, animal bedding. That's why it depends on the product. You know, we are baling the good thing, but it's complicated for us that we are baling all kind of solid product. That's why it's difficult to be specialized from the energy point of view. But every day, we are receiving a lot of calls, a lot of inquiries interested in producing energy. That's why this is very interesting, the job that you are doing promoting this type of technologies.
Great, I'm glad to hear that. Thank you very much. And thank you for your really interesting presentation. I would like to give the floor to Saku. Saku Rantanen is a board member of WBA. He will be also doing the conclusions today, but Saku, you wanted to comment now. Please, go ahead.
Yeah, thank you. Hello, everybody. I just wanted to comment. Maybe it was a little bit unfair question to Javier because they are not using the biomass. So we are using the biomass, so I can answer the question from that perspective. So kind of for me, how I see that it would not make much sense to first bale the biomass and then again take it to the part and then use that biomass for briquetting and pelletizing. You are doubling the costs of energy that is used for production of those. So I would say that the pelleting, briquetting, and baling would be more like perhaps like a competing or complementing technologies, depending what you use. I would say that, well, I'll come a little bit later to discuss about a little bit more about the comparison. But I would say that would not make sense to first bale and after that briquette or pelletize.
Saku, I would like to put also a question to you that was raised in the chat, which is there are hazardous components in rice husks. Is there a way of mitigating these? And it was not entirely clear what was meant. Could have been meant the chlorine component. But could also be the silica that might be considered hazardous. You are running a large power plant or heating plant, I think, with rice husks. Can you say something about the hazardous components?
Yeah. So there is no hazardous waste or hazardous components in rice husk or ash. If you burn the rice husk, you generate ash. There is no hazardous content in the ash either. So what is like? Let's say if we think about the densification, what is the challenging part of rice husk is the high silica content. So the ash content in rice husk is usually something like 20%, and from that 20%, 70 to 80% is silica, and silica is basically sand material. And then when we today talk about the densification, if you put sand through a pelletizer or sand through a briquetting machine, it is not very good material, and it's the spare part cost and wear and tear is very high. In that sense, kind of if we would look at rice husk, I would kind of and not long transportation distance would perhaps kind of go for baling in this case. But I'm happy to be challenged by the CAL or CPM or the briquetting machines on this one.
Okay, thank you for this comment. I also want to comment shortly on a question I thought was quite interesting and relevant. That it said, is energy produced from densified biomass considered to be clean? And that is a question you cannot probably answer with yes and no, because it depends very much on the technology you use to burn it. there are technologies available to use biomass in a way that it is entirely clean. And there are, of course, traditional ways of, you know, piling it up and just putting fire to it that will create a lot of smoke and you would not consider clean.
Yeah, and maybe like there's kind of two elements, in my opinion, the clean question. One is that, is it clean from CO2 emission perspective? So is it carbon neutral? And the other one, is it clean to combust biomass? So the first one, there is some CO2, but the biomass as itself, it's considered CO2 neutral. So when you burn biomass, you don't emit CO2 in kind of CO2 calculation methodologies. But then when you transport biomass, let's say you use trucks, you use diesel in the trucks, that is CO2 emission that biomass emits. Or if you handle it you bale it, or you briquette it, or you use conveyor belts, they consume electricity, and that's emitting CO2. Kind of in the Asian context, typical CO2 emission reduction, if we compare it to fossil fuels like natural gas, we reduce 80% or more CO2 emissions if we take into account all the processing cost and transportation cost. Then the second point is does it burn cleanly? So then that kind of depend. Let's say that you can burn biomass in very clean way, but you need a pollution control system in your boiler in order to manage those. But I would say that all the biomass, we can use all different kind of biomass and build pollution control system that it can burn very, very clean.
I agree with that. I agree with that. Thank you, Saku. And that leads us to another little poll that we have prepared. And I would like to ask you, what keeps you from becoming a WBA member? Because I assume that many of the ones that are here present in this webinar have not yet considered to become a member. And as an association, obviously, we want to increase our membership to be able to offer better services to our members by having more resources from members. So please have a look at this. If you're not a WBA member, only answer this. If you are, it doesn't make a sense, but I suspect that many of you are still not. Why is that the case? Have you never thought about it? Are you not aware of the benefits of membership? Are you not sure whether we are delivering any value? Do you consider our membership fees too high or too low? Because having very low membership fees also puts into question what value you can actually generate. So I tend to believe the membership fees are too low, to be frank. Yes. Or do you believe bioenergy sector doesn't need a global interest organization? Or are there any other reasons for you not to join? So please take your choice. If you're not WBA member, to say why are you not a member? Single choice. Okay. I'm not aware of the benefits of membership. Well, that's a great opportunity for us to present the benefits of membership to you. And many of you have not even thought about it. So I guess that's also quite a likely motivation. So great. We do have a second one that is also related to the membership issue. If you would become a WBA member, what services would you be most interested in? Please also give us a short idea. Is it that you think that advocacy for bioenergy at the international level is really important? Or would you be more interested in updated information on bioenergy, on markets, on policies? Would you value the opportunity to network with bioenergy stakeholders? Or would you prefer to have access to showcase your products to a platform that allows you to promote your services and projects, please select what would be the most important benefits of a membership that you are considering. So let's see what are the results. So updated information is the thing you would be most interested in, and the opportunity to network with bioenergy stakeholders. Well, both of these things we can in fact offer to you, and I would like to give the floor shortly to our Managing Director, Bharadwaj Kumamuro. Bharadwaj, can you just give a short introduction into what WBA offers to its members?
Perfect. Thank you, Christian. I'll be very, very quick to ensure that I don't eat into Peter's time for his presentation. I hope you can all see just a couple of slides. First of all, thanks to the speakers for joining us, and thanks to all the people who've joined to this particular webinar. Briefly, as Christian's pointed out, our mission is to promote the increasing utilization of sustainable bioenergy and also to support the business environment for bioenergy. This map kind of shows where our membership comes from. As you can see, a big cluster in the European Union, but we have members from different parts of the world, and it's very interesting to know as to why some of them have not joined us. So it will be good to have more wider representation as well. And in terms of the membership, we've got associations, technology companies, equipment manufacturers, producers of biofuels, research institutions, and so on. So we are a very wide network of bioenergy stakeholders. More information is available on our homepage. And just speaking on the points which we had in the last poll on what are the reasons why anyone has to would be interested to join as a member. First, in terms of information, we are kind of a clearinghouse for anything related to bioenergy, by our publications of statistics, by fact sheets, by our mission reports, give you the latest information on developments of bioenergy around the world. The second opportunity is also an opportunity to network, like right now what we are seeing in the webinar, in the chat function, in the discussions we see. In better situations, of course, we would have, we've been organizing study trips and workshops and conferences pre-COVID times, but right now we're doing quite a few webinars, and these gives an opportunity for members and bioenergy stakeholders to network. The third benefit is also we provide a global platform, whether it's a promotion of your products or services or projects on our website or on social media. And I just want to highlight, last month we've agreed and have Bioenergy International as the official magazine of WBA. It's one of the leading publishers with the latest developments of bioenergy. So I would highlight everyone to look at Bioenergy International and to know more their services as well. They're now our official magazine, and this together with our website and social media gives you a wonderful platform to promote your technologies and products and projects. And finally, most importantly, is bioenergy advocacy. There's a lot of debates and discussions surrounding bioenergy, and we feel that our presence, whether it's, for example, in the picture you see, our presence at the COP25 conference in Chile, that was a press conference we had organized. So our focus is a lot on promoting bioenergy, advocating for bioenergy at an international level. And these are various membership benefits most of our members get. So what are the next steps? If you're more interested to know more about us, please log on to our website, worldbioenergy.org, or do send us an email at info@worldbioenergy.org as well. And we'd be happy to get in touch with you and to discuss more about your technologies and products and services and how we can collaborate further. So thanks again, Christian. I give you the floor back to you.
Thank you very much, Bharadwaj. So that was a short pitch, and I hope you will excuse us using this opportunity for this pitch. And I will now give the floor to our final speaker, Peter Code from CPM Europe. CPM, again, one of the very long-standing technology leaders in pelletizing, and also a long-standing member of WBA. Peter, the floor is yours.
Good afternoon. Well, depending on which part of the world we're in, of course. It's very good to be invited today to join this forum, and yeah, I will endeavour to give you a run through on densification of agricultural residues for energy from the CPM perspective. My name is Peter Code, as you've said. I'm the Biomass Business Segment Manager for our biomass group worldwide. We have active markets in a lot of different countries throughout the world: Europe, Russia, Southeast Asia, India, Southern Africa, yeah, North and South America, of course. Yeah, so many solid biofuels and such potential. So many agri-wastes in different types and different forms. As everyone has said, solid biomass pelleting is not easy, but with a suitable CPM production unit, it can be successful, of course. Which forms of biomass are burnt? Well, you can have chip materials burnt, or the baled materials, as our previous speaker said, the briquettes, as CF Nielsen provide, or pellets. Pellets is a very large market in the world, and this is the one I'm going to talk about today. So from pelletization, yes, it's a standard method for large-scale production of high-density solid energy carriers. Pellets are manufactured in several sizes and grades as fuels for electric power plants, industrial power plants, homes, and other applications, as we've seen already. There are two basic groups that the pellets are made in: industrial standard and non-industrial or domestic standard. We'll more or less work through on the industrial today. If I take India area as an example, there's just a vast array of different raw materials available and a vast tonnages. In fact, you could say that if you added all these up, you have some 10 million tons of material readily available if it was actually available to the market and there was infrastructure in place to use it. If I zone in a little bit closer on that, and I go to some of the more readily available units, there are quite some similarities and differences between them. And we see the moisture can vary between 8 or 10 and up to 55%. The particle size of these materials is quite different. Some are bulky, voluminous, some are sticky, some are gritty, and yeah, all sorts of different things. And then you have moistures and ash contents, as everyone has discussed. So from very, very high ash contents when you compare to wood to reasonably low areas. And of course, bulk densities are also changing. Now, some of the influences of this raw material, yes, it depends on the region and the type of material coming in, the input form of that material, the age of the material, the moisture content of the material, and the ash content. And control of the incoming material is very important to any of these processes. If I split the plant line into two sections to make it easier for us to see, we can call the first section the wet side of the plant. And the material coming in, well, it needs to be stored. Then it needs to be cleaned. It needs to be shredded or ground. It needs to be maybe dried depending on the moisture. And to dry it, we need a buffer before and a buffer after. Just to go through these sections. The raw material storage. A lot of these agri-waste residues, yeah, it's quite complex due to their short harvest season. And to get them out of the field into a place where you can use them, there's a very short window in many cases. And so infrastructure needs to be put in place if these farmers are to stop burning, to get this material efficiently off the field into a storage facility where it can be stacked or covered and kept in a reasonable condition until it can be processed further. Also, with different moistures or different qualities of material, they need to be segregated and held so that they can be blended later. Also, different species of or types of material, need to be segregated and being able to bring through as a recipe or blend to be added together to make the final product. This feeding can be manual with bales, as we see, as bulk material coming through, and within the plant itself, they can be manually, semi-automatically loading shovels, or with conveying systems, debaling systems. All of these things are in useful use. The baled materials, as we saw from the other presentations, need to be if they're used to bring the material and store it, well then to bring it through to process for a pellet, it needs to be debaled and then shredded. And there are various different types of machines on the market, such as bale shredders and tub grinders. After the material has been taken into the plant, it also needs to be cleaned in some way to take out the abrasive, as much of the abrasive materials as possible, to remove rocks, grit, dirt, foreign materials such as metal may have been picked up along the way, and also to try and reduce the ash content of the abrasive elements as much as possible. And this cleaning can be done by sieving, washing systems, and metal removers. If the material needs to be dried, and in most cases, if it's 15% or more, it will need to be dried before the pelleting. Then there are various different drying systems available, either drum dryers with high temperature systems or belt drying systems with lower heat input systems. Moving on then to the dry side of the process. After the material comes from the dryer, it would normally be buffered to allow a split in the plant, so the pieces of the plant could run independently, but also to give the material time to stabilize after drying before it passes through to pelleting. After it has come through the dryer section or the input section, it will most likely need to be further ground to get it down to a piece size, or particle size that is useful for burning later. In this case, we would advocate a hammer mill grinder. And from the hammer mill grinder, the material would pass through a moisture control section and then through the pelleting, afterwards to cooling and sieving, and then outloading. The process of dry grinding can be difficult enough with these very high volume bulky materials, as Olaf alluded to earlier. From CBM's perspective, we have developed a slow speed hammer mill with very large screen area, plus a large casing around the unit to give extra space for the material to flow through and pass out through an open base. And this has proved very successful. After the grinding, it's very important for pelleting that you get a homogeneous mix of materials, but as in raw material coming from the input side, but also after drying that the material is stable in its moisture level, so that you get a continuous flow through the pellet mill and a continuous quality of material. So in that situation, we would advocate moisture measurement and water dosing with control system on, and after any moisture addition, that the material would have time to ripen or mix and stabilize before it's pelleted and then fed through to the pellet mill. From that situation, yes, you can pellet the material the perfect setup is somewhere in the 8 to 10% region, but coming from a dryer, it may be needed to be a bit lower to try and stabilize the material coming through. So then we would add back some moisture and narrow our pelleting width to give us the best moisture to give the quality pellet. So bringing up a little bit of moisture in the system, so bringing our average up to the 10-11% road. If it's much higher than the 15, then you see the pellets start to deplete. A quick look at that then, if I look at 10%, this is straw pellet, but 10% moisture gives a really nice pellet in this situation. As the moisture increases, the bulk density starts to decrease. If you move up further to 14%, again, your bulk density is further falling and you're starting to see cracks in the pellets. And when we get to the very high moisture of 22%, our bulk density has nearly halved, and the pellets are very fragmented and won't stay together very well. So this gives a good indication that moisture control through to the pelleting is very important. And that brings us neatly along to the pelleting process itself. The CPM machine is a vertical ring die machine. It has been in the market for many, many years, a very robust machine. After the pellet or the raw material has been processed through the blending, the grinding, the drying, then it is passed into the machine and pressed between the rollers and the die into a continuous production of consistent quality pellet. After pelleting, of course, there is the cooling process and some sieving of any fines off the material back into the line. And then you have, of course, packaging or loading, or either bagging or bulk loading outside. Some points to consider about this particular, it's quite difficult raw materials and so many different sources. So for the client wishing to pellet this, you really need to think about the raw material source and the suitable storage to get that raw material into the plant, because you want to run your plant up to 7,000-8,000 hours per year, running continuously to give you the best throughput and also the money back and the best profitability from your plant. So proper raw material processing through this plant should be tailored to that specific raw material to get it as best a quality from it. Of course, purchasing the best equipment and installing it in a good line with very good process control is very important. Also, well-trained staff at the site, making sure they know how to optimize the machinery and keep the material flowing and do any maintenance. Because this material really has very high ash content, there is definitely a higher wear content for materials through the line, not only in the pellet mill, but everywhere through the line from a wear and tear point of view. So, realistic operational budgets for this higher abrasive material needs to be taken into account. Also, planned maintenance routines based on quality wear parts and not having constant breakdowns from using substandard equipment will make your plant much more profitable in the end. Just to finish up, CPM makes a large number of very robust pellet mills. These pellet mills are built to operate all day long in very tough conditions. And we have been in the biomass business for more than 30 years and have produced more than 600 pellet mills into that markets. Our machine is a direct driven single reduction gearbox, no nonsense designed with good technology and such things as oil lubricated rollers to increase our lifetimes and bearings. We've also developed specialist dies and rollers for these high abrasive materials to try and reduce as much as possible the wear element to keep the machine running as long as possible for you guys as clients. Well, hope that give you a quick run through on how a biomass plant should look. Thank you for your attention, and back to the panel.
Thank you very much. That was a wonderful wrap up of what pelletizing of agricultural biomass involves, and was really extremely educative. Thank you, Peter. I would like to ask you a question, and that is, I mean, we have seen a huge increase in pelletizing of woody materials. So from a few million tons 20 years ago to more than 40 million tons nowadays. Do you see a significant uptake of pelletization of agricultural biomass already? Do you expect it? Where's the relevance in terms of market volume? What's your take?
Yes, the wood biomass, yes, is still growing in some areas, but we're seeing a massive increase in inquiries across the world for agricultural waste residues. So far, that these plants are in their infancy, and that's mainly due to getting this raw material in, and the various learning processes required to get that through a good plant, and also to find good sources of burning for this. And you know, as with all of these biomass plants getting started, incentives and grant aid and things are very necessary, plus low interest rate loans and other things. So yes, I believe there's really a huge potential for this in the next number of years, and we are seeing a lot of inquiries and some plants being built.
Fantastic. That's very encouraging to hear. Thank you very much, Peter. And this brings us almost to the end, and I would like to give the floor to Saku Rantanen. Saku, a board member of WBA, is running and building plants that are using agricultural biomass as a fuel, and he will kind of wrap up the discussion and draw some conclusions from what we have heard. Saku, the floor is yours.
Okay, thank you, Christian. So I'm actually very excited. We have heard like a full presentation on like leading companies in the world when it comes to biomass densification. So very pleased to have you all presenting here and sharing your knowledge on the densification. So I'm trying to add a little bit more flavor to the picture by taking a little bit perhaps risk by comparing these different technologies from my personal perspective, and it is perspective of from Asian industrial use of biomass. So it doesn't apply, the same rules doesn't necessarily apply in Europe or more developed markets, but my view is more for agricultural biomass densification for Asian industrial use. And if we look at the four different options, first is pelleting, the second one is briquetting, the third one is baling, and the fourth one I have introduced is non-densified biomass. So these would be basically options if you are using biomass for industrial applications. And I will share my view on each of these. Happy to be challenged by each of the technology providers. But how I see pelleting is that for agricultural residue pelleting in Asia, the absolute key is to find market for your pellets. It's not the technical solutions that much. It's not, pelleting is most complicated if I compare to briquetting and baling. It's most complicated and you really need to know what you are doing, but there are good companies to help you with that. But it's really to find the market. And if we now look at the market in Asia or globally for that is cross-border traded biomass, it's almost all of it is only wood. If we look at the statistics, there are some agricultural products also trade, like in Asia it would be bulk kernel shells from Indonesia and Malaysia to Japan, but it's almost only wood. I would say. And pelleting is the, I would say, very strong technology when we are talking about wood. Then and especially, let's say, if we are talking about wood and providing large-scale coal power plants that are co-firing biomass, and especially if they're using pulverized coal technology, then the wood pellets are the kind of sweet spot for those plants. For agricultural pellets, my experience is that it's very difficult to find buyers and find markets today. And kind of how I see is that it's perhaps very easier to build than trying to supply to the markets that are small, is to kind of build your own plants and supply agricultural biomass to your own plants, or supply it to, especially it's easier to design boilers to use different kind of agricultural residues than modifying the agricultural residues itself. If the agricultural residues have high silica content, design a boiler that can use higher silica content, or if high potassium content, design a boiler that, or lower the combustion temperature so that you can burn that efficiently. That's easier than trying to manipulate the agricultural residues to meet the global requirements that are usually wood-based quality requirements. So then I see kind of wood pelleting is like gold standard. It's much more processing than for example, baling. It's also more expensive per ton to produce wood pellets than it would be for other elements. But there are uses. Also, wood pellets are much more expensive than other agricultural biomass. And then if we look at the briquetting, I see that in the Asian context again, briquetting is more used than pelleting in the inter-country trade. For example, in India, there's quite a lot of briquetting and a quite active market. And for example, in Vietnam, there's an active market on briquetting for rice husk. And I would say that the pelleting is more for long distance. If you want to transport biomass from USA to Europe, or from Vietnam to Korea or Japan, then the pelleting is typically used. And then briquetting is, what I see in the market is that it's usually used shorter distances, meaning maybe 300 kilometers or 150 kilometers, and in intra-country trading, not that much cross-border trading for briquetting. My understanding, again, I'm generalizing because each project is different, each biomass is different, each energy cost in different countries are different, so it's very difficult to give like universal rules. But what I see that usually the briquetting cost is lower compared to the pelleting cost in the places that I have seen. And then the third option is the baling. It's quite interesting, perhaps a little bit more, although they have, IMABE have a lot of experience, very long experience, but a little bit more newcomer in the bioenergy industry, very interested to see how that will develop in the future. But if we look at the energy consumption and the cost per ton of biomass, it's low compared to briquetting and pelleting, and that makes it very interesting. The density is lower. I think rice husk, maybe I'm wrong, but let's say rice husk, you can get density of maybe 350 to 400 kilograms per cubic meter with baling. With briquetting, or let's say with pelleting, you can go maybe, I don't know, up to 600, and briquetting is I think somewhere between. So let's say that if we compare, or maybe higher briquetting, but if we compare, yeah, it's higher. So when we compare baling to briquetting and pelleting, it's lower density, but it's lower operating cost as well. So that makes it usually more competitive in shorter distances. Like let's say we below 300 kilometers, but again, below 300 kilometers is like let's say Southeast Asian country with low labor cost and relatively low fuel cost. But depends again, very much varies by country by country. But I would see that low operating cost will be beneficial for briquetting in shorter distances and in the country. And then the non-densified biomass depends, but I would say that when we look at the project, in many cases, the non-densified biomass becomes the cheapest option for at least a vast quantity of biomass that you need in the one project. But then your sourcing distance for the biomass is limited to very much shorter distance, depending again, but let's say 150 kilometers, 100 kilometers, or 50 kilometers, depending on the density of the biomass. But again, what I said earlier is that non-densified biomass and designing the boiler to feed, boiler or the furnace to be able to feed that non-densified pellet biomass is very good option to consider kind of when you're considering baling or briquetting or pelletizing. Also, one thing to analyze is that how about if I don't do anything and I change the boiler design so that it can take non-densified biomass. But then your sourcing area is smaller, and then your sourcing risk is higher because your sourcing area is lower. But maybe with these words, I could hand it back over to Christian, and happy to be channels with the professional in different technologies.
Thank you very much, Saku. That was a very helpful, I think, wrap up from the perspective, of course, of an industrial user, right? You are an industrial user, and from that perspective, I think that was a very good way of describing the differences between the different technologies of densification and of non-densification. From a different perspective, things may look differently. For example, if you look at the domestic use, I see in Europe, the domestic use goes very much towards the pellets. They're most convenient for domestic use heating and much more widely used than the briquettes. But I also believe that, for example, for cook stoves in Africa, pellets can be very attractive in gasification stoves that work almost as cleanly as LPG stoves. So I see a huge potential there in this new technology of gasifying cook stoves and pelletization of agricultural residues. So, but that is another story that will be discussed in another webinar. And with that, I would like to close our webinar. I would like to thank all the participants. It was great to have you here. And please stay tuned. We will continue this series of webinars on the use of agricultural residues for energy. You will find this webinar also on our website. And please do consider to become member of WBA, get in contact with us. I'll be happy to see you here in a couple of weeks' time when we do our next webinar. Bye-bye to everybody.
Bye.
Bye.